All right, great. We can get this going. And Google search. Okay, so our topic is Google search, and we'll make it about halfway through, then we'll call it a day. Okay. So what we'll cover, how search works, why it's needed, how it's evolved, and some basic search principles and techniques. And then on Thursday, we'll get into a little bit of this advanced stuff. So search is one of those things that nowadays everybody uses, and most people don't think too much about it, right? It's just something that's there. If you want to find something, you type in a few words into Google describing what you want to find, and most of the time you can probably find it, right? So you try to describe what you want, hopefully the machines deliver what you want. Now, one of the reasons why search engines did not always exist, obviously. In the early days of the internet, there were no search engines to speak of. They arose as a consequence of the kind of data that was available. So let's consider an example from the paper document era. Suppose you're a business and you have a large stack of invoices. And anytime a customer wants to go and file some complaint or customer service request or just look something up from an invoice, they call Susie at the front desk. And they say, Susie, I've got a question about invoice number 123456. And Susie will dig through the stack of invoices, which are already, sorted out into file cabinets in order. And it's pretty easy to find what she's looking for, right? She knows file cabinet 1 holds invoices 1 to 99,999. File cabinet 2 holds the ones from 100,000 to 200,000. So she knows it's in there. And there's different drawers that each hold like 10 or 20,000 invoices each. And she can scan through them pretty quickly and find out what she's looking for, right? So if you have data that is sorted on one dimension, like numbered invoices, right? You have one variable that these invoices are ordered by. It's pretty easy to look up what you're looking for because it's easy to sort that information and then retrieve it according to that number. Gets a little bit more complicated if you have data sorted on multiple dimensions, but not too bad. So multiple dimensions, think phone books. Anybody ever seen a phone book at your grandparents' place or maybe in a museum somewhere? Yeah, it's a big, thick chunk of paper, right? It's kind of like a book full of phone numbers. Anyway, that's what a phone book is. If you want to look up somebody's phone number, you have to have their last name and their first name to do a good job of it, right? Because they're ordered last name, then first name. So what you do, if you know their name, there's little tabs on the side of the book that show, the range of letters in each section. You go to the approximate point in the book where you think, yeah, it'd be about here. Flip it open. If you overshoot, you flip back a few pages. If you undershoot, you flip forward a few pages. Eventually, you converge on the page where the person's phone number must be. You scan through the columns to find the specific person, and boom, there it is, right? So still, these phone books, they could hold like a couple 100,000 numbers, and it did not take too long to look something up. Much, much faster than digging through the whole stack, okay? Finally, categorized then sorted, like music downloads on Amazon. Now, suppose you didn't have a search feature on Amazon. This would be kind of a headache, right? Because number one, a lot of songs might appear in multiple categories. Number two, the way Amazon is going to sort the songs, right, the way they have them right now, it's not really by name, and it's not really by album or year or anything. What they're in order of is pretty much in the order that Amazon wants to promote them, which generally means the order in which they're selling. The most popular ones are going to be at the top because they're easy to find, and Amazon knows that's what people are looking for, and it wants to sell them. So if you're looking for one of those songs, right, that's one of the currently popular ones, yeah, it's not going to be too hard to find. It's going to be, you know probably what category it's in more or less, and it's going to be near the top. But if you're digging through to find some older song that's, more obscure, yeah, it's going to be a big headache to do. And this brings into the idea of how data is indexed, okay? So indexing basically means you're sorting data along one variable. So for example, with invoices, if I call up Susie and say, give me invoice number 123456, that's easy. It's already sorted that way. If I call up Susie and I say, hey, Susie, this is Doug. Can you find me my invoice from October 17th, 2021? That's harder, but if the invoice numbers are strongly correlated with dates, like they probably are, That's still not going to be too bad to find. She can flip through the invoices, and pretty soon she'll start seeing the October 17th, and she can flip through all of those until she finally finds mine, right? It is more work, but it's probably manageable. But if I ask Susie, hey, Susie, this is Doug, can you sum up the total of all my invoices from 2020? That's going to be a huge headache. She's literally going to have to search through every invoice from 2020 to see if it was from me, right? That's going to be a big headache because it's not the variable that the data is indexed on. If the data were indexed by name, then there would be like one short segment of all of my invoices, and Susie could just pull out those and look at them quick, right? But the invoices are sorted by invoice number, not the customer's name. Same thing for phone books, right? If you want to look up a phone number and you know somebody's name, that's pretty easy to do. We can all understand that, right? But if you want to look up somebody's phone number and all you have is their address, or God forbid, you know, just their first name. Hey, I met this girl in a bar. Her name is Jane. And all I remember is the last four of her number. It ended in 0012. And you got to scan through all the phone books for all the Janes, right? Good luck with that, right? Because the data isn't sorted that way. Anyway, so this is what I'm talking about. If you have data that's easy to sort, it's easy to find stuff. If it's sorted in a different way, it suddenly becomes a lot harder to find what you're looking for, okay? One of the worst cases that we see is web pages. Web pages are very, very hard to sort, bordering on impossible using these kind of ordinary methods, because web pages do not have a defined structure. There's not like in an invoice, you know, every invoice is going to have an invoice number and you can sort it on that. For a phone number, everybody's going to have a name. You can sort it like that. Web pages, you know, yeah, maybe every web page has an author and a title, but that doesn't really help people find what they're looking for in most cases, you know? So let's talk about the problem of web pages. Web pages were a really different kind of data that required very, very different search approaches to let people find what they were looking for. So on a web page, the basic stuff you'll find is text. So there will be text. But on top of text, there's also web objects, things like images, buttons, scripts, input fields, stuff like that. And there are also going to be what are called formatting instructions. So we'll talk about that in a moment. But web pages have all those different things. So text can be there in a bunch of different fonts, colors, styles, as hyperlinks. Objects can be included on the page. They might appear in, you know, one web page might have a completely different set of objects from another web page. And additionally, objects themselves have their own metadata, things like labels, like what their display priority is, right? Should they be shown in front of the image, in front of text, or beside it, whatever. Their preferred size, so they appear correctly on different hardware. If it's images, it might have some tags built into the image talking about what the image is, stuff like that. And because these web page elements can be combined in pretty arbitrary ways, pages can't be meaningfully ordered. You can't come up with a simple system that says this page should appear before this page and this other page should appear before that other one in the list. There's no real way to make sense of that. Okay? All right. Is everybody still with me at this point? Okay. Now, next thing, markup languages. So to talk about markup languages, we have to go in the Wayback Machine to about 1990. Okay. So in 1990, the internet still existed, but we had internet, sort of. But one issue was most users had computers with a standard font, right? And I'll mention that Macs were a notable exception, but Macs were also super expensive. I remember seeing the first Mac maybe in '86 or so. They were kind of new, those little, you know, yeah. Anyway, and you could print text in different fonts, and it was super exciting. It's like, oh, wow, it's the future, right? But most users had computers with a standard font. And because of that, you'd see these ridiculous things like people trying to make giant images out of text characters. That was something you saw a fair amount of in the 90s. But because hardware couldn't display different text styles, there was no point including different styles in web pages, right? They were pretty much all just plain text, right? So you'd have some text document that you hold. All right. Well, people like having different fonts and styles. And eventually, computers came to have that as standard, right? It was pretty typical for every computer eventually to say, yeah, we can allow text to be displayed in different fonts. Well, at that point, web page design had to follow, right? And how did they follow? Well, those old documents that used to be just text were now being marked up with tags specifying how the text was supposed to be displayed, right? So things like bold or italics, different sizes, different fonts, etc. Okay? And the basic format you see, HTML, which stands for Hypertext Markup Language. So markup language is just the ability to format the document to say, hey, this part should be shown in this way. Hypertext means it also shows hyperlinks. Okay, so hypertext markup language would do something like this. You'd have some basic text like the quick brown fox jumped over the lazy dog, right? And if you wanted to have fox show as italics, you could just put a tag in front of it with an I saying what follows will be in italics, and then you could have a closing tag saying this is where the italics ends. And if you want, we pull this, go to oh, we are not good. We go to an online HTML editor. Okay, so we'll use this one. By the way, if you see this weird acronym here, WYSIWYG, that stands for what you see is what you get. So it's not some kind of scary security feature or something. Anyway, ooh, it didn't, that's weird. We're gonna fix that. There we go. Okay, so you can see the text I have here. Fox appears in italics. Okay, because that's what markup language is. I said, yep, I'm going to display it this way, and I'm going to mark up this little bit like I'm some newspaper editor, and I'm going to say this is in italics. Okay. Now, we have a bit of a more complicated article in a moment. So, markup languages, again, they specify how text and objects are presented. HTML in particular, which is the standard language for writing web pages, relies on those tags, that text inside pointy brackets explaining how content is going to be displayed. Now on the next page we have an online news article. There's going to be different tags displaying, specifying things like headers and subheaders. There's going to be the article body, which is going to not be enclosed in any tags to speak of, and that'll use the default style. And individual words in some cases, I'm going to specify special formats for them. Okay, so we go to the next page. And we can copy and paste the same stuff in. Okay. So first of all, this H1 tag, this H1 tag here at the start, H1 is for the primary header. So it's the biggest text, right? So it says McDonald's to start selling donuts. Great. The second one, H2. Okay. H2 is a secondary header tag. So it's going to be bigger, but not as big as the primary header. Okay, this P, this is a paragraph tag, meaning that the text inside this stretch here is going to appear separately as a separate paragraph with a little bit of spacing above and below it. Strong here, this overrides the B that's in the slides. It's, the current way of doing that. It still understands that B is for boldface, but strong is the more current way. Same here for emphasis, EM will be italics. So you can look here in the text and you can see donuts here appears in bold. Fresh Delicious Donuts here appears in italics. And this last bit here, this is a tag for a link. So I'm going to add this here. I'm going to do something different. So A is for a link, but at this point, the link doesn't point anywhere, so it doesn't go anywhere. It just appears as text. But if I add an href attribute, which stands for hyperlink reference, I can specify where the link links to. Now at this point, you see it automatically turned into a link. It's underlined there. It's not just regular text anymore, but I got to specify here where it goes. So I can do that with https www.mcdonalds.com. Okay, and now when I click on the link, when I hold Control and click on the link, it takes me to McDonald's. Okay. So anyway, that's HTML. HTML is the language of web pages. And again, if I had written this and put it on an ordinary web page, this is how it would appear. Okay. All right. So key takeaways. At this point, I do not expect people to know a whole bunch about HTML. We will do some lab exercises around it. The last three will be web design. So you do HTML and a couple other things, CSS and JavaScript. And if you don't know what those are yet, that's okay, because we'll cover them in the lab exercises. But what you should know, the two basic things: markup languages are languages for specifying how a document is going to be displayed. Okay? And HTML is the markup language that is used for web pages. All right. Now, back to online search. So the core process within matching content to search terms is plain text. Okay, so you look at text in the document. However, that text can appear in different places with greater importance. For example, you could have some terms appear in the page title. You could have them here appear in headers. You could have them appear as ordinary text in paragraphs. Clearly, most of the time when you're searching, you're looking for a page that matches what you're looking for. So the page title naturally describes, or ought to describe, what the page is about. So if terms occur in a title of a page, that's going to be more important. It'll be considered a better match than if they just appear in headers or plain text, right? Likewise, headers should describe in some sense what's in a section of the document. So having terms appear in the headers says, well, maybe this whole document isn't about the term, but at least a big chunk of it is. And so that's considered a better match than just finding the terms in ordinary text in the page. Also, terms can appear as metadata for images or other objects. So for example, suppose I go to Google Images and I need to find images of pineapples for some reason. Okay? How do you think Google finds those images? Do you think Google has some super smart algorithm that looks at every picture on the internet and says, this one looks like a pineapple. This one looks like not a pineapple? Probably not, huh? It would be a lot of work, and there would be a lot of trial and error involved, wouldn't there? Yeah. You guys seen Meet the Mitchells? People have seen Meet the Mitchells? Yeah. There's this one family that survives the robots taking over the world, trying to destroy all humans. Anyway, there's a bit at the end. So they have a dog, which is a pug. You guys know what a pug is? Yeah. So they have a pug, and the pug, most of the robots cannot tell the difference between the pug and other animals or bread. They're not sure, and they kind of makes them short out when they look at it. They try to identify, this is a pug, this is a dog, no, it is a pig, no, it is bread, and they fight and they short out, okay? Because it's really hard to do that stuff. But pineapples have all these images have metadata. They have a bunch of tags specifying, basically, this is a picture of a pineapple. And they have other tags like fruit, or they might have, stack of pineapples, or they might have top of pineapple, cut pineapple, whatever. They're going to have different terms in the metadata that Google can use to match the images to the terms. And that way, Google doesn't really have to know. Google just kind of has to take their word for it. But of course, eventually if people never click on an image, it's not going to show up very high in the listings anyway. I bet if we scroll down far enough, we can find some weird stuff that doesn't quite look like pineapples anymore. Yeah, see, now here's like pineapple drink. Pineapple is maybe a bad example. Wonder how far we got to scroll. Here's a dog looking at a pineapple. That's weird. That is not a pineapple. See what I'm saying? So they do not have, yeah, they just go with what's in the tags. Okay. Other stuff, right? So besides text, Google looks at other stuff. Google is willing to tolerate some imperfection in the search because it knows that the humans make mistakes. So one thing to do is look for synonyms for terms. So if you just type in bugs, Google will assume you probably mean insects, because or creepy crawlies generally. But if you include some associated terms like computer for computer bugs or software bugs, Google is going to think, oh, you mean defects in the code, those kind of bugs. And you'll see a lot of results around that, not so much around insects. Likewise, if you have a misspelled word, BGUS, Google might think, well, maybe you were trying to spell bogus and missed the O somehow, or maybe you were trying to spell bugs and you transposed the U and the G. As it happens, the truth is somewhat weirder. So I'll show you. It used to do bugs. It used to do bugs, but it doesn't anymore. So now when I do BGUS and I do search, it still suggests bogus as a term, interestingly. But when I do the search, it now gives me Bowling Green State University. BGSU. All right, so I don't know. That's what it apparently figured out was a better match somehow. But if you do some context on that, like if you say software BGUS, then it says, oh, the inclusion of the software overpowers, this other stuff, which might be, a really close thing, calling it Bowling Green. But if I do software BGUS, then it's going to say, yeah, software bugs. We know what you meant. Okay? Anyway, so yeah, online search, again, the big thing is text. It appears in a variety of ways. There's other content that Google looks at, but the big thing for matching is text. Now, ideally, when you're doing a search, you would come up with some search terms that uniquely correspond to one page. But as we will see, this is much tougher than you might imagine. So let's do some weird words. Who's got a weird word for me? Weird words. What? Categoric? I'll go with categoric, okay. We could probably do weirder than that. Ooh. Serendipitous. Okay. What? Xylitol? Xylophone, okay. All right, that's kind of weird, but I'm going to say xylitol would be weirder, but okay. And I'm going to throw in what's arguably the weirdest word of all, Ziziva. But we can't use that because that links to a bunch of word lists. This is it's actually a bug or a tree that the bug exists on, but it is the last alphabetic word in the English language, and it appears from some weird stuff. So I'm going to pick up a couple of oddball ones. Let me think. Ooh, no, don't. Dichrotic, that's a good one. I think that means it has two pulses. I used to know what it meant. Now I just know it's a word. And apophagy. Aha. All right, and we'll see. These are some weird ass words, right? And we still get 32,000 results. Why? Because a lot of these are just going to be lists of words. They're going to be lists of words either for people that are playing word games where vocabulary matters a lot, or for computer science stuff where they want to, develop search engine algorithms and scan through lots of text. For whatever reason, no matter how weird the words you come up with are, literally tens of thousands of pages. Okay? So there's no hope. If you try to do something more common, like imagine if I say COVID test, immediate results. Boom, 284 million results. You know, and people have trouble with this. People have trouble with finding terms that help them get to what they find. And it's not that people aren't smart necessarily. I mean, being not smart isn't going to help. But my wife is smart, but she has trouble coming up with good search terms. There was a time, like a year or two ago, we were trying to schedule an immediate test for our kids for their school stuff. And she was like having a total freak out because she was like typing in terms and there was a bunch of, you know, junk in the results and she couldn't find what she was looking for. She's like, fine, you do it. And I was like, yeah, type in some term. And, you know, the fourth result was like this CVS near us that was going to, you know, get an immediate test that day, had appointments available same day. And, you know, she was pretty salty about it, but that's okay. Life goes on. We got the appointment. Anyway, so this is not always as easy as you would think it should be, right? Sometimes there's going to be a lot of results that you're not looking for gumming up the search results. And in particular, common words are often found on an astoundingly large range of sites and pages. So we can look at very common words, right? Very common topics on pages is maybe the more correct thing. So sports is a big one. Sports gets about 12 billion. How about that? If I do, the biggest one I saw this morning was news. If I do news, I get close to 20 billion matches. Okay. What else? There was some other stuff. I mean, music actually gets a little less than sports usually. Yeah, substantially less that time. What do we got? News, music, sports, money. Money is usually a good contender with sports. Yeah, a little more, right? A little less than sports had, but still pretty close. Anybody think of anything else? I mean, don't say porn because, you know, let's keep this safe for work. Food? Food might work. Let's see about food. No, still about 11.6 billion. Anything else anybody want to try? Yeah, that's probably not going to be in the billions though, but I guess we'll see. We'll just do COVID. We're going to be less restrictive. Yeah, about 11 billion. That's a good one. All right, so what I'm saying, if you're looking for a topic, there can be a whole lot of pages, even if you think the topic's going to have hardly any, you know, things. The exception is usually if you tie something weird to a name, right? So I'm going to zip back a couple pages. This one, if I add on someone's name to this, like my name, then it breaks down the results very, very far because almost none of these things are going to actually have my name on them. And if they do, it's because they're probably some kind of scam site that, you know, is trying to install stuff on your, you know, machine. But here in that case, I got 41 results. So that narrowed it down quite a bit. All right. Anyway, practical example, imagine if you're looking for a shoe sale, right? So you could find the word shoe sale on number one, a shoe retailer, as in shoes for sale, but you could also find it in an article about a shoe sale, right? Maybe some blogger is talking about some shoes that they bought at a shoe sale. Or you could find the words separately, you know, on a completely irrelevant page. They could be, you know, in completely different paragraphs. So Google has to deal with that. So some matches are better than others. Clearly, an article that's about a page that's belonging to a shoe retailer is much more likely to be what someone searching shoe sale is looking for than any of those others, right? In most cases, if you're looking for, you know, you want to buy some shoes, you don't want to pay too much, you might Google shoe sale. Yeah, but you don't want to get those other pages mostly. So that brings us to the concept of context. The way terms appear on a page actually matters. Again, obvious stuff. If words are in the title of a page, that indicates that the page is about that topic. That's going to be important. Going to be much more important than ordinary text. Likewise, header text is going to be not as important as the title page because it only pertains to a section of the document, but it is going to be more important than ordinary text. Likewise, distance and sequence. So finding the two words shoe sale together in a sentence is going to be a better match than finding the two words on the page but separated, right? And it's going to be much better than some sentence like, I went to Target for their annual sale on socks. Ironically, I lost a shoe there, where the two words, they're not only widely separated, but they're actually in reverse order. So distance and sequence matters in terms of finding what's a better match. To a point, repetition also matters. If there are more instances of a phrase on a page, that tends to let somebody know, yeah, this page really is about that topic, right? So if you're a shoe retailer, it's very possible that you have a bunch of pictures of different kinds of shoes all on the same page, and they're all going to say something like, you know, these shoes, sale price, whatever. You could find the two words in multiple places on the same page, and that would count for something. Terms can also be affected by other terms used in the search, right? Like we saw for software bugs, but especially if they radically change the meaning of the phrase. So if you look for the term Cubs near Chicago, chances are you're going to get search results about the Chicago Cubs. But if you go to, say, Western Australia, where nobody really follows American baseball, they probably don't get a lot of search queries for Chicago Cubs over there. And the query there might be, you know, for animal cubs, like bear cubs, wolf cubs. Maybe there's some new ones at the zoo. Maybe somebody asks, hey, what do I do, you know, if there's a wolf that has a bunch of cubs growing near my barn, something like that, right? That might be the sort of queries they're getting out there. So anyway, other terms can combine to create what are called semantic units, where they have a separate meaning, separate and distinct from the individual terms. So Chicago Cubs, we understand that that refers to a specific thing, a baseball team, right? It's different from the word Chicago Cubs separately, okay? Also, Google looks at things like user location and history, right? So it looks at what are people in your part of the world typically meaning when they do this search, right? Which again, could be very different, very, very different. If you're like in the United States doing a Google search for baseball, the results you'll get will probably be, you know, MLB heavy. If you're in Japan doing a search for baseball, right? Even if you're using English letters for it, you're probably going to get more about Japanese baseball. Probably. I don't know. I haven't been in Japan to try this thing out. I did pass through an airport there once about 15 years ago, but that's, you know, I wasn't thinking about this course that I hadn't written yet. Anyway, and also your own personal history. So prior searches that you've done, Google is going to consider them. Like if you have just done a whole string of searches about baseball, even if you're in Western Australia, if you then search about Cubs, it'll probably think, oh yeah, you mean the Chicago Cubs because you have this history of looking at baseball. So again, in a variety of ways, context matters in terms of the search results you get. Now, intuitively, if you think about it, the more terms you include in the search, the less likely it is that any pages will have them all. And if you include rarer or more precise terms, you're going to get a better fit in terms of relevance, right? So if you can pick words that do a very good job of describing what you're looking for and only what you're looking for, your whole search process is going to go easier. There aren't going to be many matches. Really relevant matches are going to be closer to the top, and the associations between the terms will be more meaningful. Okay, so for example, if you're looking for a COVID test and you say immediate results, right? COVID test, immediate results, yeah, you'll probably, immediate results, they're going to see that as essentially a semantic unit. But if you search for COVID-19 as opposed to just COVID, you might miss out on a lot of places that are just advertising it as COVID test, not specifically COVID-19. Give an example. So suppose you've been assigned to look up some historical Rust Belt information, okay? So you start off looking for unemployment statistics. So we go unemployment statistics. And if you just do a search for unemployment statistics, you're mostly going to get a lot of big picture stuff, right? Federal level data from Bureau of Labor Statistics, you know, news articles that are again at the national level, stuff like that. Here we do find some state ones, so that's fine. Okay, but that's most of what you're going to find. If somebody's just looking for unemployment statistics, there's going to be more people looking for national level data than for any specific subunit of the country, and so that's what's going to show up on top. But you say, okay, well, I got to dig in a little more. So I'm going to say unemployment statistics 1982. Okay. That's getting better. You're getting stuff about 1982, but again, it tends to be national level stuff. It tends to be people who are looking at the overall state of unemployment. There was a recession, you know, 40 years ago. and there's a bunch of stuff. There's articles in here, but maybe you're not really finding what you're looking for. So you decide to look up Rockford, Illinois, which for a little window in the early 80s had the highest unemployment in the country. And that's what you want. You say, oh, here you start finding articles, right? We even have articles in the New York Times. So Rockford is in trouble, unemployment highest in the country, blah, blah, blah. You know, Rockford lowers its sights, that's for sure. All right, stuff wasn't good. All right, I was there. It was not a good time. Anyway, but that's, you know, again, you can include more search terms to, you know, converge in on what you're looking for. Okay. So next thing, why search is essential. So way back when, again, circa 1990, the internet could operate like a big message board. People know what message boards are? Yep. Anybody not know? Anybody want me to tell you what a message board is? You want? No? You're good? Okay. A message board basically has a bunch of topics, and within those topics, people launch threads about them. So, you know, if you had some kind of message board for, say, packback topics, you might have one, you know, list for Amazon topics, one list for Facebook, one list for Google. And anytime somebody wanted to start a new topic, you know, they'd type in a question and people could discuss it. So the internet was basically that sort of framework in the early 90s because, number one, there weren't many information repositories, right? It was basically a handful of research institutions and government agencies, and that's what there was. And so if you were involved at the internet at that point, you kind of knew where to go because there weren't that many places where stuff was. The content that was there tended to be very organized and grouped into categories. For example, suppose there was some physicist at some university, say University of Illinois, doing some research, and they were, I don't know, they were chasing down the, you know, the mass of, I don't know, the Higgs boson or something, which they only recently discovered, but still, right? Suppose that they were, you know, doing experiments for that. It would be pretty easy to look up that, you know, Professor Jones was doing experiments to calculate, you know, to determine the mass of the Higgs boson and, you know, do some stuff with that. Find it. If you knew a few of these things, if you know the professor's name, that he was in physics and that he was in the University of Illinois, you know, and it was some active research thing that was going on this year, it was pretty easy to dig through and use those terms. And, you know, you would find a small subset of things that were there. And if you were looking this stuff up, chances are that, you know, you only had access to one of them anyway, some project you were involved in. So it was pretty easy to find what you were looking for. And they had these, you know, I described them as clunky command-driven tools, basically like the command window in Windows. Okay, so that's what computers were like 30 years ago. This was the pre-Windows era. So we had something called DOS, and if you wanted to navigate through your file folders, you had to type in text commands to go from one folder to the next or display all the files in it. It was really a lot like that because, you know, it worked well enough, and that's what people were used to. But over time, you had more pages and more problems. Number one, vastly more websites and data, right? By the mid-90s, there were a whole bunch more than there ever were. Number two, this was the real problem. I mean, it was bad to have a lot more places where data was and to have a lot more data. But if you could still sort it, if it were still very well organized, it wouldn't be a big problem. It would just be like a bigger phone book or a bigger stack of invoices, right? But web pages were starting to become not easily or precisely categorized. You had all these human interest articles, right, that could be tagged in a variety of ways. You had articles about sports that would be on like baseball or football or hockey or the Olympics, whatever. And again, if people are looking for something about a particular baseball team, you don't want to just type in baseball and grab every article about that. If you're looking for an article about the Chicago Cubs, you don't even just want to type in Chicago Cubs and pull every article about the Chicago Cubs. It very quickly became difficult for people to find what they were looking for. So some website stats here. 1991 is where, you know, these first websites began to happen. By the end of the decade, you start actually seeing a visible number there. So the first, you know, the first number is 500 million. So seeing one thing there is probably around the order of, you know, 10 or 20 million websites. I don't know the exact number off the top of my head, but it's starting to become, you know, a little bit significant, or no, probably more like a few million. maybe 3 to 5 million, I don't know. I'm just estimating pixels in my head. But again, very quickly grew to close to 2 billion, nowadays. So there used to be very, very few websites. Then they went to millions. Millions was already a big problem. Google came around in the late 90s as a thing that was very much needed by then. Likewise, Webpage Weight, the amount of stuff on a web page, that too spiked a whole lot. So this particular chart ends several years ago, but that doesn't matter because it kind of tapered off past then anyway. But if you look in 1995, the average web page only had 2.3 objects, right? So the green line is objects. That means it maybe had a link and an image, maybe once in a while an input field, right? That's about 2.3. So there wasn't a lot there to work with as far as anything other than text. So if there wasn't much on the pages besides text, text was still a pretty good way to check web pages, right? Because there just wasn't much else there. But within 10 years, the amount of stuff on web pages massively spiked. And you can look at, you go to a page on Amazon now, and there's all kinds of links and pictures and input fields, lots of objects there. Same thing for the average size, not just text, but like everything that's on the web page. Early on, it was about 14 kilobytes. So, a few pages of real world text, maybe the occasional image to bring it up, a lot. But by, within 20 years, it was well over it was close to 2 megabytes per page. And it's surely got to be much more now, right? Maybe not crazy more, but yeah, got to have a lot more just because images are higher resolution. So again, the web page, not only were there more websites and a growing variety of topics on the web pages of those sites, but the pages themselves were becoming more complex. All right, so there was a lot more data potentially to work with if you could figure out an algorithm to do it successfully to deliver search results, but it was going to be a lot more work to dig through all that. Okay. Now, search as a product. Users pretty much, they want to find good search results, which we classify as being relevant and safe, and they don't want to think too hard to get them. They don't want to work that hard. So it's nice if you have a user-friendly interface, right? Something that, your 80-year-old grandmother can use just as well as you. Number two, it's very nice to have an immediate response, right? You don't want to type in some stuff and have wheels turn for like 30 seconds while it tries to figure out what to send you. And finally, you want to have relevant and safe results. You don't want to have your search results packed with a bunch of junky pages that are either, just ads with no meaningful content or, even worse, some sort of malicious site trying to put bad stuff on your machine. Now, between search engines, relevance is the strongest differentiating factor because even if you're returning results a little bit faster, if those results are junk, people aren't going to like it, right? If you return a list of like 20 search results and it's like 18 junky pages that have, nothing in them, the users, they've got in, they got to go, they got to check it out, they got to come back, they got to try a few before they figure it out. It's not saving any time. So if a search engine could deliver great results within 0.6 seconds versus so-so results in 0.5, most people would be willing to wait that extra tenth of a second, right? They're not really going to notice it anyway. The other thing, correct relevance assessment starts requiring additional stuff beyond simple term matches, right? So 1991, yeah, term matches, file data, you could look up that with a fairly simple match. But what do you think might be useful? What's some stuff that Google would have that would be very useful in helping users get relevant results? How would you measure whether something was popular or not? So you would look on who clicks on what links in the search results. Yeah, that would be sensible, right? But what about if a lot of users click on a search result and then they end up coming right back and clicking on a different? Would you think that that was a good thing or a bad thing? Probably a bad thing, right? So yeah, clicks are good. It shows people that at first glance they think, yep, this looks good. But if a lot of people are checking out that page and immediately coming back and checking out a second page, that gives Google some information that, hey, maybe that, you know, wasn't that good, right? On the other hand, if a lot of people are clicking on that link and they're staying there for a while, Google doesn't see the people immediately backing back into Google, then Google says, yeah, okay, they probably found what they were looking for. That's great. Okay, what else? What else might be good for Google to have? Yeah. Yeah, that could be, right? That you could find which subgroups are interested in which pages and they could identify you. Yeah, they generally did not have that data in the 90s. It's even kind of iffy to get these days. Basically, it relies on people volunteering that information, yeah. But that could put, you know, there's a variety of things that you might say, well, clearly one thing you might do along those lines is IP address, right? Because Google definitely has to have the IP address for people so it can send them the results. And if you didn't know, IP addresses are definitely correlated with geography, just like phone numbers are. So the way that they're distributed out over the world, Google, based on your IP address, Google has an idea of your physical location. So it can group together users that way. Okay? Yeah. Anyway, and you could, if they were really wanting to be advanced, they could look at other things like time of day. For example, Google might identify that if somebody is doing a search for pizza in the evening hours, they're probably looking for pizza delivery. Whereas if they're looking for pizza information at like 9 in the morning, maybe there's somebody, you know, doing research on pizza or how to make pizzas or something like that. You know, it could be different topics will have different patterns over the course of the day. So yeah, stuff like that. Google can do quite a few things along those lines to try to determine, you know, beyond just the simple term matches, look at, you know, what stuff is actually relevant. Other things it can use, it can accept user feedback. So back in the day, Google did a lot of this when it was tweaking its algorithms. There would be like things where you could report a site as basically being junky, you know, and then Google used that information to find attributes of junky sites and set up an automated process to do a really good job of filtering them out of the search results. So yeah, there's a lot of that sort of stuff that happens too. Okay, now way back when, again, before the World Wide Web, or think pre-1994, internet search was a lot like searching for a particular file on your computer. Sorry, my shoes have gone awry here. Shoelaces, they're bugging me. Okay, so you had all these organizations that were on the internet and they stored their data in files, right? Think about, you know, documentation about research projects or the actual results, things like that. And then the search tools just help people locate those files. So anything that you would use to look for a particular file, just like you might on your own machine, you know, you type in the file name, or you type in when you think it was made, or you type in some information about the research project, things like that. Yeah, they could help you find the files fairly well. But as the World Wide Web dominated usage, right, not just this stuff where you have research guys looking at each other's research, now you have ordinary people like us going around the internet, you know, to look up sports scores and stock prices and news articles, right? When you can see the next showing of whatever movie, all that kind of stuff. You need a lot more complicated system, a lot more sophisticated system to deliver relevant results. So the first problem was just the factor or term weighting. So imagine if somebody enters in a string of 6 words for a search query. Should the first word be more important than the 6th word? Should they all be the same? Should the 6th word be more important than the first word, right? And how should that go anyway? On top of that, what sort of groupings matter, right? If you find a pair of words that has a distinct meaning, right? So something like Chicago Cubs, distinct from just Chicago and Cubs separately, or New York City has a distinct meaning apart from those 3 separate words. How do you group those? And how do you recognize that it's significant? Second problem was if you had a very simple matching model that just wanted to look at which pages contained which words, it was really easy to break that just by packing a junky page with lots of text. So imagine that you've identified that a lot of searches are happening for people who are in the news. So you grab a huge list of all the famous names you can, right? All the big athletes, the movie stars, the news people, music people, politicians. You pile your site with all the names you can find and throw in a bunch of related topics like Academy Awards and presidential election and a lot of numbers for years. And pretty much any search that anybody does is going to find that those terms appear on your page, and your page has a shot of ranking high and getting seen. This was a problem, right? Because again, once people started to figure out that, oh, I can have a better match for my terms by including more search terms, the bad guys started, fixing that by saying, oh, you know what? Well, we're going to be one of the few sites that actually has all those terms. So we're going to show up high in the listings. And filtering out that kind of garbage was, again, another big challenge for Google. Okay. So there were a lot of different firms, different search models that were all trying to win what I call the great search engine war of the 90s. I'm hoping that term sticks, but we shall see. There were a lot of operations that were fighting to win. In the end, Google won, but the last real competitor standing, because I'm not including Bing on that, the last real competitor standing was Yahoo, which was trying to seriously compete with Google. But it didn't take. In the end, though, it costs a lot of money to build an effective search platform, right? There's a lot of technology has to be included. You have to have a lot of hardware. You have to have a lot of very smart guys thinking about how to do these algorithms. And then you actually have to implement it successfully and make it run fast. It costs a lot of money to do that. But the good thing is, once you've set up that platform, every new person who shows up, you can service them at minimal cost. Meaning, if you can show ads along with search results, if you can find some good way to show ads that are relevant with searches, you can start bringing in bags and bags and bags of money, right? And if you have these economies of scale and you're growing fast, you are denying those same economies of scale to your competitors. So they'll probably never get them, right? And that's, again, what happened to Google. It not only was growing fast, but it was growing fast as a consequence of the fact that it was actually delivering better search results than any of its competitors. So it already had a better platform. With more budget, that platform only got more accurate and more profitable, and they pretty much crushed everybody. So Google prospered essentially because, number one, very simple ad-free interface. It was easy to use. There's a little text box. You typed in some stuff. Other search engines would show ads even when you went to the first page, or the search results would be packed with ads. Second, Google would incorporate learning into their search model. They were the first operation to do a really good job with this. Not saying they were the first to try, but things like filtering out junky pages and tracking which search results are better based upon users' click behavior and upon their backtracking behavior. Factors like that helped out Google a lot. Anyway, if you're interested, you can read, there's an article there, it's from 2016, but it's about stuff that happened in the 90s. So, anyway, you can read why Yahoo lost and Google won. Okay, so as far as relevance, of course, Google wants to give high quality search results, right? It wants to show people the stuff that they're looking for. However you define high quality, right? The best, most trusted, most popular results should tend to rank higher in the search listings. And that's going to encourage people to come back and use Google again, right? They tried some other garbage search engine. It took a long time to get the results, and the results weren't very useful, and you had to pick through like 10 links to find one that was actually decent. They're like, I'll try Google next time. Now, as an alternative to learning, some of these operations tried to do what's called paid inclusion. So ideally, these relevant results could be provided by some, essentially a human-like equivalent software, system. Basically, like if you were a human and you could very quickly look through all the web pages, you would look at them and say, yeah, these pages are relevant to the search, these ones not so much, right? That's about the best Google is going to be able to do. But humans obviously can't do that, right? They can't analyze millions of web pages in real time. So you have to set up an automated system to do it. Well, one of the early attempts before, because they couldn't figure out how to do these learning models, one of the early attempts was paid inclusion. And the idea with paid inclusion was that yeah, there are these lots of junky pages out there, but they don't have much of a budget. They're just hoping somebody stumbles onto the page and accidentally clicks an ad and they make a little bit of money off that. But these other sites that are legit retail sites, they'd probably be willing to pay a few bucks to have their site listed higher in the search listings. And you know what? We'll take that money from them. So the good side of that is, yeah, at least for retail categories, it did tend to results from these junky pages and push up legitimate retailers higher. But the downsides, number one, it didn't actually work for anybody that wasn't willing to pay. So if you had an informational category, you know, they just were like Wikipedia. Wikipedia wasn't going to pay for that. They didn't have the budget to do it, right? So the bad, ultimately, is that the search results don't reflect true relevance. So you say, well, yeah, you have some seller who's willing to pay a few bucks to appear higher in the listings, but you don't know if they're there because people actually like it, or it's a better match, or just because they paid a few dollars more, right? In most cases, yeah, they paid a few dollars more. Now, Google doesn't do that with its search results. Its search results are what they call pure, meaning the search results proper, they appear in the order that Google ranks them. Now, there can be ads around them, and for the ads, yes, of course, Google will take money to show one ad in a different place better than its competitors. But the actual search results, they are ordered only by Google's best estimate of relevance, right? Google doesn't take money to show them in different ways. However, there are some areas like Google's marketplace where businesses that are doing a lot of business with Google, they do tend to have their listings bump a little bit. And the simple reason is not that Google's directly taking money for it, but what happens is this. If you're an organization that's doing a lot of business with Google and fairly frequently updating your content, what that means is Google's going to send out spiders more often to your pages to get updates on the status of things on your page. And just like Facebook, Facebook wants to show the feed in a fairly sequential order, right? So more recent posts tend to appear above others. Same kind of thing with Google. Google says, well, we just want to give people the most relevant information, and so that's what tends to be at the top there. So it's not directly that these businesses are saying, here, Google, take 10 bucks and list us higher, but if they are doing a lot of business with Google, Google's going to send out spiders to search them more often, and when they have updates, that's going to be reflected in Google's marketplace, and the sites will be listed closer to the top. So yeah, for all practical purposes, it's kind of the same thing. All right, but again, not with Google search results. Now this is where we're going to end off. We're not going to finish this whole slide, but I just want to introduce the topic. We'll come back and wrap all this up on Thursday. So early on, one of the insights Google had was that more important site, well, no, that's not even where I want to go. Google observed that more popular sites drew more traffic, right? Which makes sense. It's kind of obvious. That's kind of the definition of more popular sites, right? But just like we talked about with recommender systems, you have a problem where some content becomes popular because it's popular. It's the same kind of thing. So Google was recommending these popular sites, but because they were popular, they tended to stay at the top of the stack, right? Even if there was a new, better, more relevant site out there, if it wasn't getting much in the way of traffic and it wasn't showing up high enough in the search listings for people to go there very often, it wasn't going to register for Google that this was a good alternative. So Google had a real problem just with this, trying to work hard to deliver more relevant content. And we'll talk about Google's ranking model and some issues with that. But this is a good break point. So I guess we're going to end it here because that's where I ended the morning session. And that's all I've got. I'll see you on Thursday. I will see you guys too.